Thank you for introducing my presentation, Mr. Chairman, ladies and gentlemen. I'm going to show you some results about a research project that we have carried out in southern part of Italy, just to test the possibility of developing and implementing early warning systems in controlling the quality of drinking water during its production, from the caption to the tap through the distribution system. What is an early warning surveillance system? It was defined as a real-time automatic monitoring system which can control the water quality at different locations from the catchment area to the tap, to the consumer tap. This kind of system is able to provide a baseline of the water quality conditions which are monitored continuously in real time and not at a particular moment of the sampling, but during all the time of the system. And it's possible to establish a sudden change, and in some cases this change after the analysis can result as a warning for the contamination in the drinking water. So these systems are able, from the ideal point of view, to identify the presence of contamination prior to human exposure. This is the main intent of this kind of systems. The case study I'm just going to show you refers to the implementation of two different systems in an Italian water supplier, which is called Acquedotto Pugliese, and it is located in Apulia, in the southern part of Italy. And this is a representation of the distribution system. We can see a lot of different pipes that start from the water supplies, superficial waters, which are located mainly in this part of the Apulia. We have 5 different water treatment plants to treat the surface water, and we have also a lot of different wells which are located in this part of the region. The distribution network is very long. It's one of the longest distribution network which is located in Europe. We have about 21,000 kilometers of pipes and other systems, and it covers a surface of 19,000 kilometers to 2, and we have about 260 municipalities subdivided in 5 provinces, with 4 million of inhabitants served by this kind of distribution system. So it's a very important distribution system. And it's a very difficult system because surface water is treated with chlorine dioxide to reduce the formation of thialomethanes, and groundwater is treated with sodium hypochlorite. Then they are mixed along the distribution system. The first aspect, which is very important, is monitoring the cyanobacteria in surface water. This kind of bacteria can be present in particular moment of the year, and can affect the quality of the drinking water if we don't take into account the production of some toxins produced by this kind of bacteria. And it's very important to reduce the quantity of cyanobacteria which are introduced in the water during the caption. Otherwise, it's very difficult to control the concentration and also the production of cyanotoxins into the water, which are, of course, important from the sanitary point of view. And you can see a fluorescence probe which was mounted at the catchment area that produce some results about the fluorescence at different wavelength to measure the presence of cyanobacteria. This kind of probe was located at 3 different depths along the dam, which is the point where the surface water is abstracted and introduced in the following treatment plant. And as you can see from this probe, it's possible in different moments of the day to monitor the concentration of cyanobacteria. Of course, the concentration of cyanobacteria is different at different depth, so we can choose the most suitable caption pipe at the most suitable depth, just to reduce the quantity of cyanobacteria which is introduced in the treatment plant. And so to reduce the stress of the treatment plant, and finally to reduce the final concentration of cyanotoxins into the drinking water. So it's a simple measure, but it's very effective. Another example is the surveillance of disinfection byproducts. As I've mentioned before, there are 2 different classes of disinfection byproducts that can be detected in this kind of drinking water distribution system. One are related to the presence of the thialomethanes, chloroform mainly, but also bromodichloromethane, which are carcinogenic substances, and we have a limit in Italy which is less than the European drinking water directive limit. In Italy, the limit is 30 micrograms per liter. In the remaining part of the Europe, according to the drinking water directive, is 100, so 3 times more than our limit. And just to guarantee this quality, we have to monitor the concentration of this parameter online, just to reduce the quantity of sodium hypochlorite when the concentration go up this kind of limit. Another class of disinfectant byproducts are chlorite, chlorate, and bromate, which are produced by the use of chlorine dioxide. Chlorine dioxide is a very useful disinfectant, which is very active, and it is very independent on the pH of the water. But this kind of byproducts are very important to be monitored because they can affect the human health. And we have in Italy a specific limit for chlorite, which is not present in the drinking water directive. This limit is 0.7 milligrams per liter. And just to guarantee this target, it's necessary to monitor continuously this kind of byproducts, and not by sampling, carrying into the laboratory the sample and analyze that, because in this case we can obtain just very few points, just very few shots of the real situation. This kind of system, which is a continuous system, in this case we can see an ion chromatograph which is interfaced directly to the pipe, and in this case we can see a gas chromatograph which is connected through this kind of valves to the sampling site, and so they can determine periodically and automatically the concentration of these byproducts in the drinking water. These are the plots we can obtain. Every point is, of course, the result of one measure, and you can see a lot of points during the day, and we can control the situation in real time, both for the trialometries and also for the byproducts coming from the chlorine dioxide. Another important aspect when we treat this kind of surveillance system is how to manage all this huge flow of data. We have to determine the mean value we obtain during a period we are sure the water doesn't contain a worrying level of these contaminants. Then we have to calculate the standard deviation and set up two different lines, the mean plus twice the standard deviation and the mean value plus 3 times the standard deviation, which are trigger level. When these trigger levels are overcome by the signals, we have to analyze this kind of peak just to understand if these peaks are related to a real contamination or to a noise in the line. For example, we can see in this case this peak which are related to known events. For example, the opening of a valve which can produce a noise in the signal. So these are not a warning signal. And to discriminate this kind of signal, we have to apply some algorithm like the discrimination analysis, the clustering analysis, and other statistical analysis. So, just to summarize, an early warning system is compounded by two parts. We have some probes which are located along the distribution system or at the catchment area, and we have a very powerful PC system with very sophisticated programs that analyze in real time the signals produced by the first part. Also, this information must be combined with other different information which are coming from the health authorities, but also from other analytical results we can obtain by the laboratories. And this is the first part of the water safety plan, as you can see, because the results of this process must be combined with a management process, just to decide if this kind of signal are suitable to, are eligible to produce an event to avoid the possible contamination at the tap. So I would like to conclude with this statement made by Bill Clinton. An early warning system is a key to effective risk reduction. Thank you very much for your attention.
Thank you very much. There is now time for a few questions. We have one.
Yeah.
I didn't catch exactly, I'm not of this field, with this early warning system and the peaks and the expected versus especially the non-detected one.
Yeah.
How do you plan to manage for the non-detected ones?
Yeah. We have to say an early warning system is not a substitute for the official analysis. Official analysis are required just to determine the compliance with the Drinking Water Directive and the national laws, the national transposition of this law. But this system can reduce a lot of possibilities to obtain a contamination at the tap. So it's a good prevention system to reduce this risk. Of course, it's not a perfect system, because we have seen some false positive and false negative, but it's a system that can learn by itself, using the right software that can analyze the signals. At the end, we have a system that can prevent a lot of problems. We have applied to the Apulia drinking water distribution systems, and now they are distributing water at a very low concentration of cyanobacteria and also disinfection byproducts they didn't obtain in the past.
Okay, thank you very much.
Yes.
You introduced some possibility to control in advance, of course.
Yeah.
Especially chemical parameters.
Yeah.
Or cyanotoxin and so on.
Yeah, of
But
course.
what about microbiological parameters? I mean, you believe that they are under control, or is it possible, for instance, to think to something like the total organic carbon as something like that?
Thank you for the question. There's a lot of job in this part of research area, especially from the European Commission. They have financed a lot of different projects just to develop particular probes to examine directly the microbiological contamination in the drinking water distribution systems. At the moment, we don't have a commercial system to guarantee the safety from the microbiological point of view by making a direct determination of these contaminants in the drinking water. But maybe in the near future it will be possible, because they are going to develop some specific probes which are related to the presence of some contaminants, microbiological contaminants we are looking for. But it's possible indirectly to control the microbiological contamination by examining the level of disinfectant in different points of the distribution system, particularly after, for example, a possible terroristic attack. We have developed a project a few years ago just to examine this possibility. Thank you.
Okay, thank you.
Thank you.